You know all the ways in which we can remove moisture from foods, and that's fine. However, what we don't sometimes think about is the consequential effect of that when we consider the microbial population. So here are some of the consequences that at least I can think of when we start to remove moisture from the environment in which a bacterium may find itself. For example, the metabolic activity of an organism changes, and we can see this, and I'll show it to you a little bit later. We know, for example, that spores can tolerate these types of environments, and actually vegetative cells can also adapt and remain viable. And again, the two typical examples from the point of view of the dairy industry would be Salmonella and Chronobacter as being very good proponents of this. And then, of course, there's also this risk of cross-contamination of low-moisture foods that can arise from exposures in what we call the built production environment. And again, it's very interesting to hear the views expressed this morning in terms of taking a total look at your production site, not just, if you like, the processing chain itself, but the environment surrounding that processing chain, which can potentially influence the final product. So to that extent then, we need to think about this slightly differently, and we need to kind of put ourselves in the mind of a bacterium in terms of what it is trying to do here in order to alleviate and overcome the stresses that we as the controllers are going to impose. So we need to start understanding a little more about the bacterial adaptation then under these conditions and how do they do it. And for this, I'm going to show you the use of whole genome sequencing, or a type of whole genome sequencing that will help us to start at least to tease apart some of these issues.